So hello everyone, my name is Kris Verlaenen. I'm the gbpm project lead, and the gbpm project is a completely open source BPM project, and there's a supported offering by Red Hat called Red Hat JBoss BPM Suite. And so ever since we've extended the capabilities of our core engine to support more adaptive and dynamic cases, some of our customers have been confronted with trying to use this to model much more unstructured work. And so unstructured work, as we've basically just seen, I mean, it doesn't mean that nothing's predefined or that the user no longer needs assistance. It's actually quite the opposite, because the user, it's more complex. The user needs more assistance to be able to do the right thing. So using existing standards like bpmN2 to model some of this unstructured work confronts us with some of the limitations that these standards might have. For example, we are using the bpmN2 ad hoc subprocess to model some of this complexity, as I showed last year, in combination with rules to make decisions. But other standards like CMMN, which we've considered as well, I mean, they might also have some problems with modeling some of these unstructured work, etc. Or the end result might simply be very complex, so that for non-technical users, it's very difficult to understand. And so with unstructured work, it's very important to keep the overview, because there's a lot of things that might be happening, and you as a non-technical user, you really want to be aware of everything that's happening. And so a very intuitive visualization that everyone has used in the past in this context of unstructured work is a checklist. So both for defining what that work is up front, but also for keeping track of what you've done so far. And so our model that we're presenting here is actually very similar in that way. That, I mean, there's a number of stages, one to any number of stages you could have, and each stage can have activities, which could be human tasks or even completely automated. And in, for example, healthcare, it's a visualization that's been used often, for example, to describe treatment plans, although in a lot of cases, that's purely on paper nowadays. So we want to show you an example where we use that higher level model in the demo as well. But the important thing is it's a visualization layer. So there's a higher level visualization layer, but underneath it's all still using the full bpmN2 spec. So the developers can still rely on the full spec while all the details, so we're deliberately hiding some of the details which might not immediately be relevant for the non-expert to be looking at. We want to give them the overview, but hide some of the technical details. And so because both the developer and the analysts, because it's a layer, they will still be working on the same model. They will always be in sync, as I'll show in the demo. And so we are mapping this underneath to bpmN2, but a similar approach could easily be used using CMMN as well. And at runtime, you can obviously use the same model to keep track of where you are, whether you're just tracking stages or whether you want to see all the activities that are going on in those stages as well. So that gives a good overview of like the state of one case. But another challenge with unstructured work is looking across all your different cases, and that is because unstructured work is also typically unplanned. It's very difficult to plan up front everything that's going to happen. So what we also are looking at is a solution to make sure to help users in figuring out what it is they should be doing right now. But there might actually be so many things that they could be doing. How do they figure out what's most important? So for example, when your cases are generating a number of tasks that need to be executed, you can, and that's not a new feature, you can assign tasks to individuals based on like their load, the skills they have, the geography, etc. But what we need is more continuous optimization. That will look at always, whenever new data comes in, it will try to optimize whatever you've been doing and try to recommend what from that point of view, we believe might be the best thing. You don't have to follow it. It's a suggestion to try and optimize that. And that is because our execution service offers a unified experience where processes, rules, and planning and optimization can all be used together, because that's basically how real use cases work. They are a combination of all of these different things. So we're trying to bring back some more sanity in a world where you're confronted with a ton of things you could be doing, but we will try to help you based on the user's constraints and the user's preferences to figure out what it is you should be working on. And so for the demo, it's going to be two parts. One part will be the higher level models, I'll give a quick example of how you could use that stage-oriented model and how you can then see how the underlying bpmNT model is there as well. And the second is like once we start generating those cases, how you can basically optimize your task list in a simple example to do some of this. So let me just start with this is a first prototype version of our case modeler. And so the easy part, and so we believe that this will be very useful for non-technical people like analysts, etc., to just get started. And so first of all, let me explain that the idea is not that this is going to be a visualization that will replace process modeling, because it's actually only useful in specific subsets of processes which I call unstructured work. Don't try to do this for modeling very sequential processes, etc. It's not going to be useful. But since it's a layer, you can decide whether you want to have this higher level visualization, whether it makes sense for your users, or whether you want to stick more to, for example, the traditional bpmN visualization. So I can easily, there's different kinds of tasks you can obviously do. So this is pretty straightforward. You can just create stages, move them around, obviously move these to wherever you want them to be. And each of those have, very similar properties on what you would typically see in a bpmN2 model as well. So you have to specify, this is a user task. You have to specify what the task is about, who's going to execute it. So this is no different than how you would be modeling it in the context of like a bpmN process. But it's a higher level visualization where this can be completely executable because this actually translates underneath to a bpmN2 model. But there's not, and it'll be able to go through the different phases. Each phase, you can actually check whether a task is activated by default or whether it's more discretionary. So by default, in the demo, I'll just trigger some of these tasks automatically. But you can define under which conditions these tasks should activate. So they don't always have to be executed all at the same time, etc. And to switch to basically an example that I prepared, it's more like for an issue tracking system. So whenever an issue comes in, customer reports there's a problem. What happens is that, first of all, depending on the issue, there might be a number of people that will need to look at that issue. Typically, our first line of support is the support guys that will possibly need engineering, helping out QE to figure out whether they can reproduce it, or documentation, figuring out what might be happening there. So that's typically the first phase. After that, there's reporting of the issue and making an actual issue in our bug tracking system, etc. The actual fixing of the issue and the verification. And now this process is unstructured in the way that if you could try to model this in a very structured way, and you would typically fail because what happens is we'll contact the customer, engineering did a review, we didn't have enough information, so it goes back to contacting the customer, and then documentation comes, and they're not ready yet, so and they need more information, so it goes back to that is like, and even if we're here, we might just jump back there because we've realized we don't have all the information we need, etc. So even if you would try to model this in a very structured way, you'd have loops everywhere because you can jump from one place to the other. So we need a kind of flexibility there. If I go, and I'll basically just show this in our development environment because that's the easiest way to show them side by side. This is the same visualization of the model that I was showing. And if you look here, this is the easiest way of how you would translate a phase with activities into a bpmN2. So we're using the ad hoc subprocess, and each of the activities, they simply end up as tasks within that phase. Now, in this case, these will all be executed or triggered the first time all automatically. But because we're using the ad hoc subprocess, and that's something that we talked about last year, is that the engine is kind of giving up control on how many times they should be executed, etc. So these are, we will trigger all of these initially, but you can re-trigger them. You can decide that also, for example, the dynamic the things that Paul was explaining. So because this is ad hoc, you can add new tasks in here that are not predefined. Or you can add logic under which situations you believe these should be triggered. Like, for example, documentation review, I mean, that should only be triggered if the GSS guy added a label that this is possibly related to documentation. Otherwise, we might know that's actually not worth bothering these guys. So this is very ad hoc and dynamic, as in you can literally define the order, etc. Now, that's the most basic case. You can add more complexity here because it's not everything needs to be completely unstructured. You can end up with process fragments where we're going to file the issue, and only under certain situations I'm going to actually create that report. So it's not that you have to choose whether you want to go all the way to unstructured. No, you can combine. So this is a small process fragment. You don't want to say that the documentation needs to happen after the issue was actually tested, etc. So, I mean, I only did a few basic modifications, but you can do whatever you want. You can do boundary events, you can do full complexity, but it is still being translated into a higher level view. So basically, if I just add a task here, save this, and push this back into my server, and I do refresh this. The visualization of this model, it's a visualization layer. So this task now shows up here because we know someone has added it to the stage. Some of the details are not visible here on purpose. Like we don't see that this is actually more a sequence of tasks, etc. But that's what we're doing on purpose. We're trying to generate a model which is higher level, hide some of the details, to kind of give a higher level overview of what's happening. So if I did pre-deploy a version of this process for the demo. So if I start a new instance, what it's doing is you can see here it's basically activated those 4 tasks. There's a better way of visualizing this. I mean, so in the log, you can see I just created this, and these tasks were created. But I can look at the process model as well. And so there's 2 options. So I'm actually using the more a process admin user interface. So this is not an end user interface, but you can visualize the state of your case in this situation. And I'm using the case view. The other view is there as well. So you can choose whether, depending on who's looking or what you're doing, this gives an overview that we're currently doing all of these tasks. If you're a technical person and you want to look at the details at the bpm2 level, you can do that as well. So the model that we've developed is literally that in a lot of cases that we are seeing where the bpm2 model actually ends up being not very pleasant to look at, which is why we create a visualization that, especially for people like end users, they can keep track of what's happening as well. Okay, and then the second part is then more about, okay, we're going to be creating a bunch of these tasks. So let's assume, I mean, these issues are coming in, etc., and they're all creating tasks. And so the second part, the optimization of your task list, is something that's really, in general, not really visible. Because what it's usually doing is it's doing things in the back end which changes things so that you then, whenever you're going to your task list and you're asking, like, what are the most important tasks, I mean, the optimization engine will have figured out, okay, I've changed this task and I made that now your first priority. But we did build a simple user interface for visualizing some of this for demo purposes. So let's assume I have a team of people. There's 3 engineers. There's 1 support guy, there's 1 PE guy, and 1 documentation guy. And I just started 1 instance. So, and these are the tasks that are coming up. They're currently group assigned. So anyone can go in and claim them. I haven't assigned them to anyone specifically. So to explain, I mean, these are customer tasks, engineering tasks, QE tasks, documentation tasks. They're all low priority, which is the green arrow. And this describes the affinity of the user with the issue. So if I this is obviously a very easy thing to do. If I try to figure out what would be a good way to assign tasks to people, this is what the end result is. I could have done that myself, but you can see that an engineering task is assigned to an engineer, and similarly. So we got this green dot means that it's assigned to the best possible person. An engineer is the best person to be able to solve this issue. Obviously not that exciting, not that advanced, but I can start generating a few more of these instances. Right, so 5 more instances, which mean actually 20 more tasks. If I start solving this now, and this is a very low amount of tasks. This is very easy to solve for the constraint solver, so it almost immediately jumps to a decent solution. You'll see that because obviously there's much more engineers, they will be able to pick up some of the tasks, and they will do so, but you can see that they will be taking more time to complete a task than someone from the DAX team would be able to do. That's the yellow marker here. The affinity of an engineer with that problem is less, so it's going to take him more time to do. It's not just, if you're just going to be able to reshuffle tasks to everyone, not taking into account anything else, you'll just end up, that's going to be an easy thing, but that's not reality. So the optimization tries to take into account as many constraints and preferences, et cetera, as possible to make it as realistic as possible, because it needs to be very relevant. If it's off, so if the optimization engine is always off, people will just ignore it. The idea is that you can, because this is an affinity, and this is just one of the properties that you could use, you can define anything you want in the constraints. This will show that actually if you ask an engineer to do one of these other tasks, he'll take longer to do it. So that is the reality. Although, even knowing that, this is a more optimized plan because not assigning these tasks, they'll just end up here. It's going to take us much longer to solve all of these. Obviously, and this is like we can simulate that time's progressing. So you can't continuously keep optimizing tasks because once time moves forward, and in this case we're saying as soon as someone has started the task, we're not going to pull him off again. So at that point, these are locked. So we obviously need to take that into account. So, but assume we start now yet another instance, but I'm going to mark this one as high priority. Then if I try to find a new solution now, obviously it's not going to change the existing assignments. Sorry, I'm not sure where we were, but you can see that these high priority tasks, they've all been scheduled before all these others. And the engine is going to try and find an optimal solution. Again, now this is showing that it's fairly simple if I do this now, because it's just 4 tasks. They're all higher priority than these others. So yes, they'll just pick the first one available. But this it can be actually much more complex. This is an example of 500 tasks with 20 employees, and you can, I could let it solve for a while, but what happens in that case, it takes a while to find the first solution because there's, I'll explain a little bit something about the technology behind it, but it takes a while to get a first solution, and then it'll keep trying to find better solutions. You don't have to wait for that. So what typically happens is you can start it, it'll find one solution. It might not be the optimal one yet, but it'll give you a solution which at that point it thinks is optimal. It'll keep evolving. You can decide at whatever point you still need it. You don't need to continuously optimize. You can do it at certain points in time when new data comes in, or you can keep it running to always try and have the most optimal solution. It depends on how much money it's worth for you, because obviously running a CPU, run this in the cloud, there's a cost associated with that. And maybe just to quickly show some of it on how it works. It's based on, the constraints there's 2 types of constraints, hard constraints and soft constraints. Hard constraints, you cannot, you have to follow these. So for example, a skill requirement, which is not used in the demo, but you can add skill requirements to tasks, and then only people that have that skill will be able to get that task. There's no way of ignoring that. That is something you have to do. The other constraints, here, they're just trying to, these are soft constraints. We're trying to find the best solution. In this case, first we're going to do the high critical priorities, and we're going to try to minimize the end time. So the end time of each of the tasks, we're going to try and minimize that. And then in the second layer, we're going to do that for the major priority. So critical priority will come first, then major priority, and finally the minor priority. And the idea is that, I mean, these are just could be your generic rules. You can even add user preferences to this. I'm not saying that users will go in and write these rules. No, I mean, what you typically would have is a user interface where a person has a checkbox saying, like, do you like this, yes or no? There's a rule underneath that will then take that information into account. So developers will be writing these kinds of rules. So the constraint engine is actually using the rules to allow you to specify some of these preferences or constraints. But obviously, in a lot of cases, there's going to be a UI on top of that for input, for validation, etc. So if you want to write a rule that you only want to execute tasks that start with an A, that's fine. Your task list will be filled with tasks that start with an A, if there's any available. So that kind of optimization is especially critical if you've got a lot of unplanned work, which is, I mean, not really tied to one case. So you need to be honest, that's kind of what my life looks like on an average day. It's just literally like figuring out what I should be working on. Rather, I mean, there's just too much to do. So that's what some of our customers also need, not just the assignment to a person, but continuously being able to figure out for each person to find the best solution to make them at least as happy as possible. How am I doing on time? We got time for questions, I guess.